Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream, no engines, no libraries, and a lot of people ask me, they say, Casey, how are you able to talk while you are programming? I find it's really hard to do that. And the answer is that actually it's really easy to talk while you're programming if you screw up all the programming. So today we have our friend the Owl of Shame here to tell us a little something about multi-threading that Casey totally didn't do yesterday, and which we absolutely have to do if we don't want to have kind of an ugly situation arise in our code. I knew you were going to get me one of these days, Owl. I see you looking at me over there all the time. Anyway, let's take a look at this particular piece of shame here. This is, I think, the first really legitimate Owl of Shame. The Owl of Shame doesn't appear that often, but he appears once in a while. But this one is, like, I think, absolutely, like it's an incontrovertible Owl of Shame, whatever that means. Like if ever there was a time, like no one, I think, will ever argue that this is not an appropriate time for the Owl of Shame. So here we are in thread code, right? Here we are in the super fun thread code. And what we see right here is that I check to see whether or not the entry count is less than next entry to do. And if it is, then I go, I'm sorry, I check to see if next entry to do is less than the entry count, meaning is there anything in the queue? And if there is, I take something off the queue. I never actually check to see whether there's another thread that may have come in here and stolen something off the queue. I wrote this, and this is actually literally what I was thinking the entire time too. I wrote this as if it was single producer, single consumer. But this is single producer, multiple consumer, which means multiple people could be doing this interlocked increment, which means this code is totally bogus, right? So that is a definite Owl of Shame, and it's kind of a double Owl of Shame because the very first thing I said when we talked about multi-threaded coding, I said it on the stream. I was like, what we should do is we should use interlocked compare exchange because it lets you do the right thing easily instead of trying to be clever. I said that, and then later I was like, oh, well, I'll just show how to use interlocked increment here and use that instead. Well, guess what? That was totally not acceptable because interlocked increment is not going to work in this fashion. Because two threads could get here at the same time, both who have already done this check and then both who increment, and now one person finds that they have a number which is actually outside the bounds of the queue already, right? And how does that work? Now the whole scheme is borked. So we do not want to do that. That is totally not okay, right? Instead, what we would much rather do is we'd much rather use an interlock compare exchange, right? Because that will prevent us from making this error, and we don't even have to think hard about it. Like, we don't have to be clever, and that would keep us from being in bad shape, right? So interlock compare exchange, here it is. We've talked about it already. You give it a destination, right? And you give it a thing that you want to put in that destination, and then you give it this extra thing called comparand, right? Or comparand, I don't know how you pronounce that. The thing you're comparing to is what it means, right? And as you can see here by the description, it's like compares the destination value to the comparand. If the destination value is equal to the comparand value, the exchange value is stored in the address specified. Otherwise, no operation is performed, right? And so the long here, right, it returns whatever the value was that was there at the time. So what we can do, if we want to, is we can do this check and say, oh, is the queue, you know, what's up with the queue? Is there anything in the queue? And then we could do interlock compare exchange, right? Same exact code, where we just say, okay, do an interlock compare exchange. That will actually return us the index that we should use, right? And then what we want to actually pass in there is whatever next entry to do was before, right? So this is like original next entry to do, right? There we go. So assuming that that is less than the queue count, we do the interlock compare exchange. We want to put in there, right? We want to put in their original. Why could I not? Why did that not indent? Indent Emacs. Indent. There we go. I just had an extra parentheses in there. So we do interlock compare exchange. We say, okay, I want to take this memory address. I want to replace what is there by incrementing the value by 1, right? And then what I want to do is I want you to make sure that the value that's actually there is the one that I thought should be there. So I know that nobody else came in here and incremented it, right? Then I just go, oh, okay. If I happen to be in a situation where the index that I got back, right, equals the one that I thought it should be, then I know we're okay, right? But if I get back a different index, then I know that another thread has beaten me to the increment, and I should not do anything, right? I should not do anything. So that's what we actually want to do. And I would set result is valid equal to false there, right? Now we've got a little bit of extra work to do when we do this, because that means now there's a case where we could fail even when there actually is work to do, right? So what we could do here, I think this will simplify out a little bit. I think this will actually simplify things more. But what we actually do need to do as well, right, is we need to basically loop over this if we want to maintain how this particular function actually worked, right? But we don't actually have to do that because, hold on a second, I want to grab out the render group. We changed the API at the end of last stream, and we actually don't want it to work the way that I had factored it quite yet. I was kind of sort of pulling things out into a platform non-specific way, but then we decided to just do it this way. We decided that what we wanted was just an add entry and a complete all work, right? That's what we had actually wanted to have happen. So what I'd like to do is go ahead and pull, basically restructure things to make them into this structure so that they're working off of this, which they almost are at the moment, but just get it restructured and then go and worry about actually cleaning this up. But hopefully everyone understands my ShameAl situation there, right? Basically, I was counting on the fact that I was only having one thread that was dequeuing, which coincidentally, the reason I was thinking about that is because the thing I was thinking of in my head was a time when I wrote an asset loader which had a background thread, and it would just sit there waiting for stuff to be told to do. And in that case, interlock increment works quite nicely because you don't have to worry about that, right? But when you have multiple people who are all looking at the same queue, interlock compare exchange is way better because it allows you to very simply, without having to really do anything more fancy, it allows you to very simply go, oh, okay, just here's what I think the value was, and I did all my preparations assuming that this was the value, and now we're going to go for it. But if that value is not what's in there, then just don't do it, right? So you don't have to worry about the fact that no matter what you don't have to worry about the fact that the operation that you're about to do is always going to complete. You can abort it, basically, which is kind of nice. It's a little bit like that transactional memory stuff in a sense. It's like transactional memory for one single value, right? We're on to almond milk today, and it's pretty delicious. All right. Okay, so let's see if we can wrap this up here, because I'd like to try running the renderer today if possible. So let me see if I can go ahead and wrap this up so that we've got the renderer working in the way that I suggested that I wanted to work when I kind of wrote out this API here, right? So what we're going to do here is we're going to say that there's a call to the platform layer that allows it to add an entry to a queue, right? And so we're going to go ahead and say that, you pass a work queue in here. Here's the queue. And then you pass in, there's some kind of a function. And the function signature, I guess, just looks like this. Maybe it also gets the queue that it was working on, just for completeness sake. And then it takes some kind of a pointer. And that pointer is whatever the program wanted it to be for, like, data, whatever the thing should be using, basically. So that's what we're looking at here. So we essentially have a type def, right? We've got a function signature called do work queue or work queue callback, something like that, which is something where you can kind of register and say, okay, come give me slices off of a thread or something like this, right? And what I want to do is say, okay, we'll take that callback as part of the work queue addition, and we'll take the data that we're going to pass to it, and that will be how we add entries to the list, right? And a work queue entry storage, therefore, will just be whoever should have been called back, right? Like the callback, and whatever the data pointer should have been, right? So it's just going to store those two things. That's all it's going to do. So when we want to add entry, right, it's going to be just exactly this code that we already wrote, so that's all good. We've got this add entry here. It's going to do all of the same stuff, and remember, only one person at the moment can write to it. If we wanted to, I guess it would be possible to make it so multiple people could write to it. All we would really have to do there is, again, use an interlocked compare exchange on the entry count. So I'll add a to-do here, basically like switch to interlocked compare exchange eventually, so that any thread can add, because maybe we want to just try that out and see if that works okay. Because if it does, then we could just allow people to add work queues from any thread that they want to. Maybe that's a little too crazy, but we could try it. If it gets crazy and we get bugs and it's crashy and weird or whatever, we don't have to do it. You can always back up. Anyway, so this adds the entry in here, and now what we need to do is we need to make sure again that we write all of that entry information before we increment the entry count. So what I want to do here is I want to grab out that work queue entry. I go and grab the work queue entry that is the one in question. I then set its data member to the one that was passed in, and its callback member. This won't have to be here anymore, and its callback member to the one that was passed in as well. So we're really just copying those two in there. So there we go. So we copy those in there. We make sure that they're written out. We then increment. And technically, I guess we don't really need this anymore because we have read that Visual Studio will treat the s-fence as a write barrier, but I'll leave them both in there because it can't hurt. So, okay, we've got the queue entry count. We're going to increment it. Then we increment the semaphore. And that should be all we need to really do for add entry. Now, I guess this stuff right here is going to start giving us errors if I don't start piping it through. So let me go ahead and actually pipe it through. Let's see here. So we've got a platform work queue, render queue. So let's go to Handmade platform. And when we pass in the game memory here, I guess, maybe what I'll do is I'll stick some work queues in here. So we'll basically have a platform work queue. The platform work queue, we'll just have the render queue for now. And we'll leave that like so. And when we compile this then, we will actually need to, I guess, have that definition. Of course, we're not going to define this. It's going to be blind, so I guess I'll just go ahead and do struct platform work queue, like so. Oh, or not. That's right. We're going to have a pointer there. Because I have this thing where I'm calling off of it. Well, that's okay. That's no big deal. Because we have to find a way, we want to be able to get this function, essentially, because we're calling back the platform layer, and we want to have some way of being able to know what that call is. Now, I suppose we could make that some kind of a thing that just gets assigned, like a global variable kind of a situation. And really, we could do that for anything that we want everyone to be able to call. Because it would be nicer if we could just do this, right? And that way this is a completely blind thing that the operating system the platform layer can define however it wants, which I think I prefer. So I think I may leave it that way for now, like so. So we'll basically have platform add entry and platform complete all work. And we'll just have those be some things that are globally defined in handmade.h, right? So in handmade.h, essentially everyone will be able to use them. They're just global because there's only one possible one they can ever call, and it'll just be set by the game layer. So that seems fine to me. I don't have a problem with that. So this is a global variable. It's going to be platform add entry. It's a pointer to that function. We also have platform complete all work, like so. And so we'll get those pointers. We'll get those pointers from the Handmade platform. So again, anything that calls back, right? Anything that calls into our platform layer, we need to actually pass into the game, because that's just how we've structured things. Basically, all of the platform services get passed in at startup time. We don't have any implicit binding stuff that happens with the operating system or anything like that. So we're going to go ahead and do these two here, which means I need to type def these two guys, right? Like so. There we go. And really, it looks like these only take some very rudimentary stuff. It takes a platform work queue. It takes one of those functions. Let's take a look at, I put that in here, but I'm going to hoist that out. There we go. So this is a platform work queue callback. This is platform add entry, takes a platform work queue callback. And it takes a void star. There we go. People were saying that was a good ship name. It was actually a company name. There was a company called Void Star. I don't know if anyone knows that. It's true. So, all right. So we've got our type defs here for operating on the work queues, and that's really all we need. I think that's basically it. So over here, we got the platform work queue callback. We've got the platform callback. There we go. And I think we typically have prefixed these things with Win32, so we know which ones we're dealing with. So we've kind of got a Win32 add entry and a Win32. Well, this is going to have to be a Win32 complete all work, I guess, like so. So yeah. So I don't really know. I mean, this is the tricky part, right? I think we probably want two work queues, like maybe like a high priority queue and a low priority queue or something like that. I don't really know, right? So I think maybe what I'll do here is say that this is the like high priority queue or something. So it's like everything comes off. This is like high priority stuff. And then we'd have like another one that we would use maybe in the future for lower priority work. I don't know. That's totally speculative, but I just want to make sure. I don't want to like fence us in or anything. So I just kind of want to make sure that we have the ability to do that. So I'm going to make sure that these always talk about a specific queue all the time, just so the platform layer knows which queue you're talking about. I think I feel a little more comfortable with that happening. All right, so we've got Win32 complete all work, and that's got to basically be, you know, this is actually not what this is. We're gonna have to refactor some of this stuff a little bit. Just going to massage it around a little bit. So what we need to do here is we need to kind of take this stuff that we had, like the thread proc, right? We need to take all this stuff and we need to factor it out so that we can make it work with the API that we had, right? That we want, because we figured out how everything needs to work, but we need to make sure that we can actually do it, right? That we can actually do it in the way we want. So Win32 complete all work. I don't know why work queue entry completed. That I didn't even do that. That's a mistake. Oh, there we go. This is just a void, right? Yes. So I'm going to go ahead down here. I'm going to say that this code right here, right, which we were used to be doing, which waits which basically does the sort of like do work from the queue until all of the work has been done, right? I'm going to say that that is Win32 complete all work, right? Because that's essentially what that is. So Win32 complete all work, right? What that has to do is that has to sit there and do this check, right? Which I'll just go ahead and I'll make it right in line again, because we only pulled that out because I was thinking like, oh, maybe the platform layer will call it. But in this case, we don't have that problem anymore. So I'm just going to let that be inlined and remove this. So while the enter count is not equal to the completion count, meaning while there's still work to do, right? then we can do that work. And what I want to do here is I want to structure this so that the other call that we have, basically this Win32 complete all work, just like it was doing before, can share the do worker work stuff with the thread proc, right? So whatever the thread proc does will be the same. Okay. So in other words, these two functions here want to be able to do exactly the same thing. So this guy wants to be able to figure out if there's an entry in the queue to do, and if it is, he does it. Otherwise, well, I guess he just keeps spinning, actually, right? So really we want to do here, it's like do next work queue entry. I think that's really all we have to do. I don't think we have to break it out anymore. So we can just do next work queue entry. While the entry count is not correct, it will do it, right? Because this is the live thread, the one that's just going to keep going. And then all the other threads, what they're going to do is they're going to say, oh, okay, I want to do the same thing, do the next work queue entry. And if do next work queue entry returns, let's say just returns true, then we go to sleep. So basically, it will tell us whether to go to sleep or not, right? That makes sense? So that's it. And that's really it. So we could get rid of this as well. There we go. And so I think that's, again, much cleaner now, right? So Win32 do next work queue entry, Win32 do next queue entry. Yeah, thread info queue. And then in the future, you know, we can make this so that it tries to do work from either queue, right? Right, you could imagine us doing something where we did Win32 do next work queue entry, and if that and Win32, you know, other queue, right? We could pull from multiple queues here, and we'd always pull from this one first, blah blah blah. So we could extend that to work with the multiple threads pretty easily, I think. So okay, Win32 do next work queue entry. All of that stuff seems reasonable to me. So what I'm going to do now is I'm just going to write this function out of the pieces that we had before, which is actually pretty close to what we originally had to do. So we're kind of back to where we started, which is good. I find that I do that a lot. Sometimes I go on a little diversion and I learn something, or I see that it's not quite what I wanted, and I pull back and it's good. So yeah, don't ever be worried about that sort of thing. That's kind of the essence of programming. It's very hard to foresee things, so you want to kind of play with them until you can see it coalesce, and then you're like, ah, okay, yes, I'm sure this is good now. And again, you could kind of see how I did that. I went over to write the usage code, and that really educated me, right? It was like, oh, right, this really could be done very simply on this side by just doing this, so, you know, maybe that's what we should do, and it turns out that I think that's going to be good. So, again, the usage code is always a great guide. It's always something you should look to when you're like, I don't know what the design is here. Let me see what the usage code is. It's almost always the right decision. All right, so in do next entry here, obviously, we don't have to do this completed is valid interlocked increment thing anymore. We can actually do that down in here, right? So we don't have to worry about any of this stuff. We don't have to worry about this guy anymore, which is nice as well. And we could actually now name this actually work queue entry, which is actually kind of nice. So this is platform work queue entry, like so on. Platform work queue entry. There we go. So. Yeah, platform work queue entry. It's starting to look okay. I should probably go fix this stuff first, huh, so I can actually compile. All right, so in here, where are we at? Platform work queue callback are both defined, are they not? Oh, we need a little void in there. There we go. What is the problem? Why are you complaining? What are you complaining about? type def void platform work queue callback, and that is correct. Type def void platform add entry. Oh, that's a good spelling there. There we go. So platform add entry cannot convert argument 2 from overloaded function platform work queue callback. Is that really true? What is the problem here? Let's see. In handmade.h, we have added platform add entry and platform complete all work, so that's good. In handmade.h, we have platform add entry should take a queue, it should take a callback, and it should take some data. Oh, it's because this guy is not a thing. So here is where I would like to use the macro. Again, people don't really like the macro version, so I wasn't going to do them for these two guys. But you can kind of see why this is handy if we're going to start to have these. So I want to do this at least for this guy. Platform work queue callback, and you give it a name, and then it does this guy, like so, right? And that way I can do it much more succinctly here. I can say type def platform work queue callback, and do it like that. So I've got my type def in there. And now I can make sure that everyone always does this stuff properly. Now, I probably want to do internal here, right? Like so. There we go. All right. So I think this can now go away, right? That disappears. There we go. And now we just have to make sure that we actually pass this render queue through. And so in fill ground chunk, it would need to take the queue to use, right, for this. And we could totally just store that in our game state or anything else that we want to in our transient state. So we can just use the trans state for that. For example, we can just do trans state render queue, like so on. And I can also do that in the exact same way over here. No, not there. There we go. Trans state render queue. And then in the transient state, I'll just go ahead and stick that in there. Render queue. Oops. Platform work queue. Render queue. A compilation process is running. Kill it. Yes. I don't know why that was asking me that. Okay. So now I just have to kind of hoist some of these guys out here, or I shouldn't say hoist them out, but actually like copy them out. So when we come in, right, if we're not initialized, we want to do a couple things here. First of all, if we're not initialized, we want to take platform add entry, and we want that to be equal to memory platform add entry, and we want to do platform finish all work. We want that to be copied out as well. And then finally, in the trans state, when we initialize the transient state, right, we want to make that have the render queue be in there. Trans state render queue equals memory render queue, right? I think it was called high priority queue. So there we go. So now we just have to finish porting out this stuff. So we have to do platform work queue here and make sure all of this stuff is that way. It is boiling hot in here, by the way. This room gets hot with the computers in the summer. It is going to be a sweating Casey. All right, so now we just have Win32 do next work queue entry. Like I was saying before, we do our interlock and pair exchange. We figure out what index we want to do, assuming that there was one that we wanted to do. Now Win32 do next work entry. We are now counting on this guy to basically return true if we should sleep, right? So we should sleep is going to be false, and we're going to return we should sleep, like so on. And the only time that we know that we should sleep is if we actually saw these things being equal, right? We're just like, oh, okay. If we saw these things being equal, then we should sleep. Otherwise, we should not sleep, because either we did some work, right? Or we like tried to do work, but somebody else snarked us, and we don't actually know what the state of the queue is, so we should try again, right? So we want to make sure that we only sleep when we absolutely are positive, right? That we absolutely super double plus know for sure what's going on. All right, so I'm going to go ahead and dequeue this entry here, right? I'm going to say grab out the entry that's in the queue at that location. You know, the one that was that we were on. We're going to go ahead and actually dispatch there. So when I do the dispatch, I should probably actually do a read-write barrier here. And mm fence. And the reason that I say this is because the code that's operating in here, probably we want to make sure had the opportunity to finish all of its writes before we keep going. So I suspect we probably want that. I could put a to-do in here that said double check this isn't problematic performance-wise, but I'm pretty sure there's no way it could be. Oh, no, you know what? I don't have to do that because interlocked increment does that fence for me. Right, so never mind. Interlocked increment does the fence that we need. Okay. So we're fine. We're automatically fencing, so it won't matter. So what I want to do now is I got to do the callback. I got to do the callback, pass it the queue, and pass it the data that it wanted. Right? And that's basically all I think that we needed to do. Now we just have to go make sure that we can fix all the rest of the stuff that was like our test code and whatever. So here we go, platform work queue. There's the queue. Nothing weird happening there. Platform go. We don't need that anymore, right? Let's see. Win32 thread info, platform work queue. That looks all fine. Work queue entry, do worker work. So do worker work is now going to take a void star, right? Data. Well, actually, I'll just use the macro that I made. All right. So here's our do worker work, which is just our little test function, right? Internal. And that is just going to print out whatever we have. We don't know the logical thread index anymore, unfortunately. Although we could actually have that passed in. In fact, why not? I guess there's really no reason not to. Well, let's chill on that for a second. Well, you know what? For our test code, we totally could do it this way. In fact, and for our test code, let's go ahead and do this. Get current thread ID. So get current thread ID will at least give us a thread to print. It will not be the kind of thread number we were using before, because it will be whatever the operating system assigned, right? But that will tell us something we can see here to see which threads we're doing what. So that's fine. So here is our data. We can do our output debug string. Everything looks fine here. Push string no longer needs to be that. We can just straight up call win32 add entry, right? Because that's all we're actually talking about here. So push string becomes win32 add entry. Whoop. And let's see, work queue is now platform work queue. And win32 add entry now has to take the callback as well. So it has to take do worker work, right? So I'm going to go ahead and replace this with do worker work. Oops. Ha! That's kind of amazing. I missed the, I accidentally forgot to leave the thing in, and it made this nice stripe pattern without the quote. Without the double quote. There we go. Okay, so win32 complete all work takes the queue. Okay, so let's see where we're at here. We should probably step through this because we made a ton of modifications. to it. We also need to make a quick trip into the initialization code here, because the initialization code, before it calls anything, needs to properly set these values, right? So what we need to do here is when we set up game memory, right? And we set those debug calls, now we actually have to do like the different things that we said we were going to set. These guys have to all be in there. So we need to provide a high priority queue. We need to provide platform add entry, platform complete all work, right? Like so. So that's Win32 add entry, Win32 complete all work. And then this right here can literally just be this queue. So we can actually call it queue. So we can even use that one, right? And the only problem that we have so far is that now we don't actually, our queue never resets, right? So for the time being, and this is not the way that I actually want to do it eventually, but for the time being, whenever work is completed, so all the work in the queue has been completed, I will go ahead and at that time reset the queue, right? So right then, I'll just do queue entry count, completion count, queue next entry to do, queue, there we go, right? So that's it for the moment. Nothing else going on there. Platform work queue, there we go. So yeah, so I'll just run it just for fun, but we kind of need to step through this now and make sure that we're doing anything resembling anything, really. So okay. So here we go. We've got our threads. They're printing stuff out. Looks like we actually did work. 1, 2, 3, 4, 5. Yeah, looks good. And we have a bunch of different threads doing their thing. So that's all fine. And hey, you know, surprisingly enough, the game actually worked, which is weird. There we go. I was expecting something to go poorly there, right? I'm expecting this thing to kind of die a horrible death, but for some reason it wasn't. Yeah, and I don't know why it's not dying a horrible death. There we go. I was going to say, it should die a horrible death. It is not dying a horrible death, and I don't know why. Oh, my goodness. Pixel is like totally garbage. So that's always fun. Anyway, so we've got work to do to clean this up, but already we're actually at least working. So this is running through the threads, which is nice, right? So we're not totally broken. We're just not really good, one might say. So okay, so let's take a look here. I guess one thing, so I already know is wrong. I mean, we'll just start taking a look at things. So before I do any debugging here, what I would also like to do is I would like to probably convert this guy. Like, here's what I'm thinking. Instead of stepping through this and validating that it all works and then changing it to a circular buffer and introducing more bugs and then debugging that, I'm wondering if I shouldn't just change it to the circular buffer first and then start debugging it, so that we're only debugging one thing, which seems a little bit more sane. Also, this isn't thread safe right now, so, you know, because this hasn't guaranteed that people have gone to sleep, for example, right? So what I would like to do is I'd like to do that first. So, I mean, that even is a cause of a bug that we could have, right? So anyway, so let's see what we can do to make this into a circular buffer, right? So what we want to do for a circular buffer is we want to have essentially two, we want to sort of change the nomenclature a little bit here to just say we have, you know, a place we're writing to, a place we're reading from, and then we have a completion that's in between there, right? And we want these to be able to kind of wrap around potentially into the buffer, right? So one thing I could do in theory, like the cheesy way to do this would be to just change this to a uint64 and always just mod into the entry table, right? That would always work just fine. But since we are already doing an interlocked compare exchange, I think, and I can't think of any reason why this wouldn't be true, I think if we just use interlock compare exchange in both cases, we should be able to just handle the wrapping, and it shouldn't be a big deal. At least it seems that way. So let's take a look. Let's just take a look at doing it that way so that we don't have to worry about Q wrapping being an issue. So here's what I'm going to change these to be called, right? I'm going to call entry completion count will actually be like something like probably next entry to complete, right? Or first uncompleted entry. How about that, right? Then we're going to have next entry to use or something, or to fill, to write, and next entry to read. Something like this. And so I just want these guys to constantly go through the buffer and wrap around, right? So when we do win32 add entry, what I actually want to do here is I want to assert that the next entry to write is not equal to, I want to basically assert that if I was going to write something, into the buffer, that we haven't like wrapped around, right? So in order to do that, what I would need to do is say that if by writing into this entry, I would overwrite an entry that's already there, then that would be a problem, right? I'm trying to think of what the easiest way to do that would be. I mean, because it seems a little bit ugly to try and do that. I'm trying to think of what the easiest way to do that would be for not leaving space in between the two of them, right? It's been a long day. It has been a long day. Circular buffers at the end of a long day, it's a little rough. I'm going to bop over to the blackboard so that I can think this through. So circular FIFO here. So here we go. We've got this dude, right? He's got a bunch of entries in him. And what we want to do is we want to say, you know, if I have to read, and you know, if this is the read location, right? I need something that sort of says where I'm reading. I need something that says like where the you know, where I'm writing to, right? So I keep adding entries at that point and moving this forward. And the read, all the other threads are pulling things off of this buffer, so the read is moving forwards, right? And what I wanted to figure out is, well, when these guys are wrapped around, right? Like when if the right pointer comes around here, I just wanted to be able to assert that it doesn't go past the read pointer. You know what I'm saying? And so I guess I will just leave a space and say, if the right pointer, moving the right pointer would collide with the read pointer, you can't write. Like you've overflowed the queue, right? So I think that's just what I want to say. I think I want to say, if the next entry to write +1, right, mod the entry count, like so. If moving one forward would make me equal to whatever the next entry is to read, then I'm going to just consider that that's bogus. You've put yourself in a bad condition. Now, technically, you still could run in that configuration, right? It's the one after that would be bogus, but I don't want to. It puts the queue into an invalid state because the pointers are now pointing to the same place essentially. So I'll just leave it that way. So assuming that that's okay, then the one that we're going to get is the next entry to write. We're going to write into it, then we're going to increment the next entry to write, and we're going to release a semaphore, right? But when we increment the next entry to write now, what we would like to do is say if the queue's next entry to write equals the array count, we want it to jump back to 0, right? So in some sense, what we want to say is this. Queue next entry to write +1 mod array count entries, right? Which is the thing we wrote above. So I think what I'll probably do is just say, oh, okay, new next entry to write. I'll just say this is what it's going to be, right? That's what we're going to do. And so I'll say make sure that the new next entry to write isn't equal to the next entry to read, because if it is, that would be bad news, right? So that seems okay, right? I don't see anything problematic there. That seems fine. Yeah. That seems totally fine. So now this guy is a little bit trickier, right? First uncompleted entry is a little bit trickier. In fact, I think first uncompleted entry might not be, like, when we start making this queue be able to have more people in it, we're going to have to actually have these things be a little external. So this is, I think this is still going to be like completion count, like a different thing. And we're going to have completion count be something that actually does reset in that way, right? So, okay. So, if we do all of that, then because what we're going to have to do is have multiple completion counts. So everyone who has a job will have to have a separate completion counter. Everyone who has like a set of jobs that they need to wait on will have to have like a separate completion counter, basically, right? If they're in the same queue. So anyway, now we can do the exact same thing we were doing here, which is to say original next entry to do equals queue next entry to do, right? And that's the one that it's going to read from. So it still does exactly the same thing, but instead it does new next entry to do, and it's really next entry to read now, right? Next entry to read. Here we go. Original next entry to read. New next entry to read. And the new next entry to read is just the same as this computation up here, right? We're just doing this. Next entry to read +1, and we're modding by the entries. So we do that. We do the original next entry to read. We do next entry to read like so. We check to make sure that the original next entry to read is not equal to the queue next entry to write, so that it has not caught up to the right cursor. We then go ahead and do that exchange, new next entry to read with original next entry to read, like so. And then assuming that the one that came back was the original next entry to read, we go ahead and we do it, and we ink the completion count, right? And so that now, I think, should be a little bit more in line with doing the circular buffer stuff. So this is, oops, this is queue entries, like so. Next entry to write, new next entry to write, that's a typo. Next entry to do, next entry to read, and queue count is not to entry completion count. So again, like I said, these are going to have to be a little more general. So what we want to do here is have some way of knowing when a batch of jobs has completed. So what we really want is something that's sort of, you know, it's like we've got a completion, you know, goal and a completion target, basically. So we've got like our completion goal every time we add an entry, right? We need that to increase. So, you know, every time through here, right, we would want to ink the completion goal, and later they'd be different completion goals. And then every time in here, we ink the completion count, we then just want to see while the completion goal is not equal to the completion count, right? So I think that's roughly correct. But yeah, we're going to have to test that. It does not look good. It does not look good, ladies and gentlemen. But I think that's roughly correct. So let's go ahead and take a look at it. Oh, but this part worked just fine, which is a little bit odd. I wasn't expecting one of them to work properly and the other one not to. But I guess that just means our wrapping is not working properly, right? So what I'd like to do is to test the wrapping. I would like to set this down to a level where the wrapping is going to happen more frequently, right? So I want to do something where we'll guarantee that we will wrap and then, you know, in our test code. So what I'm going to do is I'm just going to make it so that we will definitely wrap, right? I'll make it so we only have like 10 entries in here or something like this. And then, you know, when I run it, in theory, that should make whatever's going to happen like right away, right? If that makes sense. At least that's the hope anyway. Well, I guess not, because that's in the renderer. So the wrapping actually didn't fail there, which is kind of annoying, but okay. Anyway, what are you going to do? I'm going to step through the code so that I can see what's wrong with it. I was kind of hoping that we would be able to make the bug happen right there, but I guess the answer is when you start the day off with an owl of shame, you don't deserve things to go your way, potentially. Could be one way to think of it. All right, so let's take a look inside Win32 add entry. Here's our queue. There it is. It only has a few entries here. So we come through and we push the first thing on there. There's the first thing that we picked. We now have a completion goal of 1 because there's one thing in the queue that needs to get done. We update the next entry to right, moving it forwards. We also kick off a thread, right? So that's fine. Let's jump back in here, take another look at the queue. You can see we've already read one entry, so that already got done. That entry already happened. So we come through here, we push on the callback, we do the fence, we take a look at the new next entry to write, and that's gonna to update. So that's looking fine. I'm gonna go ahead and jump ahead here to the part where we get to the wrapping boundary. So we come in here, right, and we now have a next entry to write of 9. So the new next entry to write should be 0, and it is. We come through here, we set that next entry to write is 0. The completion goal got incremented again, as it should have. So now we're going to do that sleep 1000. All of these threads printed out all the strings that we had there. So our completion goal and our count are both 10, which is what we would expect. We're on the 0th guy, so we wrapped around the queue, which is what we would also expect. So yeah, we've added in each one of these guys, goes ahead and adds in exactly as we would expect, and wraps around again. The completion goal finishes up, and off we go. So how many of these did we get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So that all looks good, which is kind of bizarre. So yeah. Yeah, we've got something more subtle that is wrong, I guess. But I don't know what it is. So I guess the other thing I can test is just to see if there's any chance we can make it be clearly about the wrapping or not, is make it very large. So this just doesn't seem to be about the wrapping at all. We're just full on not completing, right? So that seems like it's more about our that seems like it's more about our completion code, not about our actual wrapping code, which is not what I would have expected. Okay, so let's see. Here we are in the main thread. We're inside complete all work. The completion goal is 16. The completion count is 17. Haha. So we still got a race condition in here. So, okay, so this is good. We've pared it down. We now know what our target is. The completion goal code that I just sloppily added there is not correct. Well, the completion goal code is correct, or has no indication that it's wrong yet. This is the problem. Our completion count is not operating correctly. So let's take a look at what's happening there. So we know that when we come into this guy, this is the guy who does all the adding. This is the producer who comes in here. So we know that completion goal kind of has to be set correctly by that point, right? Because we set him. And then completion count, when we're checking against him and doing operations, somehow, either in the threads or elsewhere, this actually incremented a value one more time than it should have been allowed to do. So how does that happen? We have an interlock compare exchange. We are trying to exchange the entry to read with this new one, which is incremented by 1, right? We are giving it the original one that we saw that was in there, right? The one that we think is there. And then only if that was the value that was still in there are we going to actually do the work dispatch, right? So how does that end up incrementing too many times? How does it happen? Original next entry to read equals Q next entry to read. If they're not equal, we're going to try the interlock compare exchange. We're going to try it with the next entry that we computed. So that will replace these two. It will return us whatever was there, right? And this is what we're expecting to see there. And as long as that's true, man, you know, multi-threading, hard to do on stream, it turns out. So once I read that once, I have to make sure I read the correct one, obviously. Yeah, so I don't actually know that was the bug, but that was a bug, because I was reading this value twice, and I need to only read this value once. I need to look at it once and then do all my computation based on it. Because if I look at it multiple times, I could get different values each time, and then the whole thing comes falling down, right? So I need to read that once and then never again, right? So let me actually verify that I never read it again, in fact, right? Oops. So let's take a look at everything that reads from Q here. We read from next entry to read once, next entry to write once, and then we target next entry to read. That is how that should be. Okay. And hey, that turns out that actually was the bug. Bizarre. So hey, you know, this is actually pretty cool because we are now rendering multi-threaded. I don't know if you noticed that, but it's totally true. We are totally rendering multi-threaded, people. That is awesome. Now, how much of the processor we're actually using? We're actually using quite a bit more than we were before, which is kind of cool. We are not maxing it out, and that's by design. But we've roughly tripled how much we're using. I suspect at this point, though, we couldn't actually go any faster because we're not doing enough of a workload at this point, right? Meaning we're only going to render at 30 frames a second because we actually wait for the vertical blank and all that other stuff. We actually do the sleep in there, right? So we're never going to go faster than that. So I think that means we're rendering at 30 frames a second. We'll have to do some forensics and see how we're doing, start timing the overall thing. But we're getting there, people. We are rendering multi-threaded. It's true. It's actually true. Now we have a couple other things we got to work on. We got to set up this tile stuff properly, and we have a problem with how we're handling the edges of things as well now that we're multi-threaded. That wasn't a problem before we multi-threaded, so we got to look at that. But next week it looks like we can tidy this up, and we've got a pretty cool thing going on here. I feel like I'm pretty excited about this. Can we crank our resolution to 1920 by 1080 at this point? It kind of asks if you can. I don't know that that's a good idea in general, but I don't know. I mean, you might as well try it, right? It's not quite as fast, but it's still running. And boy, it looks pretty good too, huh? Let's see what happens if we just use I know you guys don't want me to use more threads because, you know, it ruins the stream, but let me just put it up to 13 threads or 11. Okay, 12 threads. Okay? I just want to see how we do. That's pretty darn good. That's pretty darn good. I mean, that's kind of crazy when you think about it. 1920 by 1080. That's pretty darn cool. I mean, can you imagine how slow this was? I mean, we were running at some ungodly, like 1 frame a second on the quarter size, and here's the full size running in like a totally playable frame rate. That is some really cool stuff right there, and we're not even finished yet, right? That is super cool. That is just awesome. That is so cool. All right. I'll turn it back down. Yeah, I'll turn it back down. All right, let's go to Q&A here. And remember, this machine is from 2010 as well. This machine is an old machine. This machine is 5 years old. It was a good machine at the time, though, but it was old. Let's see. Since the workloads don't complete in order, what if one workload takes very long while the other threads wrap around in the queue such that a new workload overwrites the slot with the one that is still running? So that's definitely a problem. And essentially, what we need to do, and there's a lot of different ways you can choose to approach this, but the way that I usually try to approach it is I just make it so that I shouldn't be queuing up that much work, basically, right? So, for example, in the circumstance that we have here, the renderer, we know it's just going to kick off a fixed number of tiles, and then it needs to have all those tiles completed before it moves on. So we can very easily just construct one high-priority queue that we know always has enough space in it to store a full render set of tiles, and that's never going to be a problem, right? For out of order, for like background loading and stuff like that, we can have a separate queue, and we can just make sure that we don't try to launch new asset loads if the queue looks like it's getting filled, right? That's not too hard to do. And so what we can do, and what I'll probably do, is make a Win32 add entry kind of a thing. I'll make this return a bool, and it will just fail to do the add, and you'll then know, the calling code will know and be like, oh, okay, the queue's full. I won't try to like launch any more background asset loads or something, right? So that's probably how we'll handle that. Now that we're multi-threaded, could we compile in debug mode and have the game run at a reasonable frame rate? Oh my god, dude. Do you know what? That was the debug build. That was the debug build. I'm going to turn it on optimization. Dude! With only 8 of the threads, we are running in real time in 1920 by 1080 right now. And that's doing full blitz too. We're not filling the ground chunks right now because I turned that off, but it's actually blitting the whole screen too, and then blitting the trees on top of it, and then the characters on top of that. So it's not that different. Like, we're gonna add a lot more complexity in there. So I mean, it's not like we can say like, oh my god, the 1920 by 1080 software rendering is totally gonna work for Handmade Hero, because we've got a lot of complexity that we're gonna throw at it, and I don't know that it's ready for that, right? But dude, and it's sub-pixel accurate everywhere, and it does scaling and rotation. We've got some serious stuff going on here. Not to mention, we're not even clipping the bitmaps yet. The bitmaps themselves are actually blitting bigger than they need to be, too. I'm going to turn on the ground chunks. Because why not? Dude, this is awesome. This is just so stupid cool. Computers are so darn fast. Like, this is literally not using the graphics card as anything other than a dumb frame buffer, and we're totally running this game in real time. Oh, this is gonna be so darn cool. Doesn't this just get you excited, though? Because now it's like, when you see stuff like this, too, it's like, it feels like there's so much just more ownership of it, too. Like, it feels so good to succeed at something, even if it's not, like, I mean, we didn't do anything groundbreaking, right? We just did the basic stuff that we have to do. But, like, the fact that we worked through it all and that it's working so nicely is just so satisfying. Because now, like, we're intimately connected with that speed. It's not like we just, like, brought up an engine and we're like, oh, hey, it runs as fast as it runs, I don't know, whatever. Now it's like, no, man, like, we did all that. And it's a different feeling. It is just different than if you just took someone's code and ran it and, like, crossed your fingers, right? And so, you know, I don't know. I think it's something people should experience. It's why I do this project. It's because it's that feeling that you don't get from just buying someone's thing and using it, right? And again, there's nothing wrong with doing that. It's a fine way to make a game, but you lose something when you do it. You lose that feeling of like, holy cow, like this is so cool that all that worked. It's just kind of neat. And again, it didn't take that long. I mean, how many hours did we spend? 30 hours, 40 hours? I don't know how long we spent on the optimized renderer. Not even that, probably. 40 hours? That's only 1 week. That's not long to spend to get such a cool experience, right? I feel like it's worth it, you know? If you care about, you know, kind of your own happiness, as opposed to just how fast can I get this thing done at a bare minimum or whatever, right? That is darn cool. Can we tell how much faster it is now that it is multi-threaded? We can. I kind of hoped I would have been done a little sooner today so that I could time this. But, you know, I was going to put in a little query performance counter frame rate. We could probably, I think we have an old one in there that I could turn on. Let me turn the ground chunks off so that those aren't taking up random spurious time. But yeah. So Win32 add entry, all this stuff, we probably should clean up a little bit of some of that stuff, but let's take a look here at the frame time. I don't know if I can re-enable this. Maybe I can. Let's find out. So there we go. 33 milliseconds a frame. All right, yeah. And we've got cycles here. This is actually also telling us the whole cycle count too. But yeah, we are totally running at 33 milliseconds per frame, which is kind of insane. If I turn off I'm just gonna see what happens at 1920 by 1080 if I turn off multi-threading. What happens, right? Because it's really easy for me to do that. I can do that. Right, so instead of queuing these, we just do them. So I pass the render queue, I pass do tiled work, and I pass the work, and I just call this thing directly, right? Like that. It doesn't. You're right. It doesn't. So this is without multi-threading on. So you can see it's kind of pokey, right? It's actually pretty good, though. It's not terrible, you know? I mean, it isn't awful. So we weren't actually that bad at 1920 by 1080 anyway. So we don't, again, because we, oh, you know what? I could take out that sleep. That's another thing I could do. So in Win32 Handmade, I could take out the sleep. So, you know, on the wall clock, if I was to crank this up, so I basically said something like, you know, what's the target frames per second? Target game update hertz, monitor refresh rate. So let's say I went ahead and cranked it up to 60, right? So we just said whatever the monitor refresh rate is, that's what we're going to do. What happened? Oh. There we go. So if I crank it up to 60, right, now maybe we'll be able to see a little bit better. So here we go. Now we're running the dude. We're running at 60, but we're only hitting 50. I'm sorry, we're 50 milliseconds, not 16 milliseconds. So we're at 50 milliseconds. Now, if I turn on multi-threading, do we hit 60? Again, really what we should be doing is just timing how long everything takes. So I should add that in, but I don't have time to do that right now in the Q&A. Holy cow, dude. I think we're actually just hitting 60 frames per second at 1920 by 1080 in the software renderer. Sub-pixel. Dude, we totally are. That is crazy. Computers are so fast. That's unbelievable how fast they go. And we haven't even, like, I mean, we just did a rudimentary version of an optimized renderer, right? Like, we didn't spend 5 months sitting here playing with pixel configuration. We haven't even looked at the cache yet. Man. Robot Chocolate Dino. Instead of asserting that the queue doesn't overflow when adding an entry, would it be better to just wait for an entry to be read if there is no space to write? I don't really like to do that if I can avoid it, because it means that it could just stall the game in the middle of a frame or something, right? And so I like to just have a constant time insertion as much as possible. Would you call this a thread pool? I don't know. You know, I don't think I've ever read what people actually call a thread pool. It is sort of that way, I guess. When stepping through multi-threaded code, all the other threads stop as well, I take it. So I think you can actually set that. To be honest with you, I feel like that's actually something that is in here. Okay, so no, it's processes that you can control which ones break. So yeah, so I guess they all always will stop. I think. So I guess I don't, let me put it this way. I don't know, there might be an option to make that happen. What I do know is that you can freeze and unfreeze threads. So once you are broke into the debugger, right, and you have multiple threads, you can go in here and like freeze and thaw threads to stop them from going or to continue. Whether you can let some run while you're doing other stuff, maybe that's not possible. I don't know. It might be that processes as a whole might just stop, and you can't stop an individual thread. I'm not sure. Can you make the number of threads an in-game configuration option? I don't know that we'll do that, but we will make it dependent on the number of threads in your processor. How long until the render is sorted? I don't know. I just don't care about the sorting very much. I want everything else to be done first because it's so much more important. But we could play with the sorting sometime soon. Oh man, did I swear? Oh, I didn't mean to. I just got carried away. Is the we should sleep still right after you change the if condition around? I don't know. Let's check it out. Because yeah, just one of the things, like, you know, you might expect me to say, no, obviously it's correct because the code's running. Multi-threaded code can have bugs in it that hide for a long time, right? So just because our code is working doesn't actually mean that it's a bug-free queue, because there's so many fancy little bizarre things that can happen in multi-threading when the multiple things are doing things in different times. It's very unpredictable. So it's always best to, if someone has a question or if you think there might be something wrong, it's always best to go read the code again, because there may be a bug in it that just did, you know, it just hasn't shown up yet, but it's there, you know, and it's just waiting for the right combination of thread things to happen before it strikes. So yes, we should sleep does look correct to me. Basically what happens is we set we should sleep to false because the default is we're just going to always try to keep doing stuff. We look to see whether or not the next entry that we're going to read is equal to the next entry to the right. If they are equal, that means we sleep because there's nothing in the queue. If they're not, then we try to dequeue something. If we can't dequeue something, we don't want to sleep because the reason that we didn't dequeue it is because some other thread got there first. So that means we really don't have any idea whether or not there's more in the queue. So we should re-enter this thing and do it again, right? So what'll happen is we'll just let it pop back out and either do this check or do this check. Well, this one doesn't do a check. It'll either do this check if it's this guy to see whether it should end the whole deal, or it'll come through here and redo it again. Why do you use #if0 instead of // or instead of comments? Because we can turn them on and off, you know? So we can turn them on and off is the reason. Because if you take a look, like for example, the stuff that I just did in render group, you know, now we've got one here that we can just do like, you know, note, Casey, this is the multi-threaded path. This is the single-threaded path, right? And I can just, with changing one character, I can do that, right? And the other benefit to it is that they nest properly. Comments don't always nest properly. So if you do like this, and I want to take out some code that already has it, like so, you know, if this was commented out, right, and then I want to comment this out, it actually ends up being bogus, right? It doesn't comment these out. You know what I'm saying? It's an error. So you want something that nests properly, and the ifs nest properly. Can you show 4K? Of course not. I only have a 1920 by 1080 monitor here, and I don't have any way to broadcast that. Twitch doesn't even do 4K, does it? I don't know. Maybe it does. Oh, good. Okay, so I didn't swear. I was hoping I didn't swear, but I don't know. Is multi-threaded code less reliable than single-threaded code? Yes. Yes, 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 and yes. That is why most good programmers that I know will try to come up with good systems that make it so that you only do the multi-threading in a very tightly controlled way. Because if you just go hog wild with multi-threading and let it just proliferate, it can be bad news, right? I really just don't know programmers who are so darn good that they just can write multi-threaded code that's tons of threads happening all over the place and doing whatever in it, and it just works, right? Like, that's usually not the case, so. So is the circular buffer recycling threads after they are done processing a tile? I wasn't clear on why a circular buffer was chosen. So the circular buffer has nothing to do with the threads. The circular buffer is just the queue. And the reason that I did that is so that you can just keep stuffing things in the queue ad infinitum, and they'll always just keep getting done. Okay, so in theory, we're back. I accidentally bumped the power cord. It's a problem. The power cord is right next to where the microphone plugs in, and I have this little tiny microphone cable. So it's pretty tough. It's not a good situation. Anyway, I just wanted to see if the code got ruined at all. Just so we could know whether we have to repair anything that didn't save. I suspect it probably did save, but let's see. Yeah, so we're totally good. So we didn't really lose anything, I don't think. I think we're good to go. So yeah. So let's just double check to make sure that we're still running well. Flog them hamsters. Flog them. So this is the thing, right, that, like, did you see how long it took, like, when I click on file, it's like an eternity, and then it eventually popped up the window or whatever? That's one of the, what you kind of saw today is one of the reasons I think I'm always so grumpy. Like, look at this. Like, what was that? We were just rendering 1920 by 1080 software rendered 60 frames a second sub-pixel accurate with full transforms on this processor using only 8 of the 16 cores that it has. And like, the people who wrote this couldn't figure out a way to just have it load up right away. That was like, they had no idea like what was going to happen there. They were like, I don't know. I don't see how we could load a text file and display it in that period of time. It's unfathomable to me. You know, how would that happen? I don't even know how that would happen. That you're talking about future technology. But hey. Yeah, so that's looking really darn sweet. I think we are probably gated by Windows now, actually. Because, again, we're using kind of a janky way to blit this stuff to the screen. So I think we're probably, if we switch to going through, say, Direct3D or OpenGL to do our blit, still doing our render ourselves, but to do our blit that way, we'd probably be fine. I don't even know what to do now. Does that mean we set the target for the software render to be 1920 by 1080 60? I feel like we can't, because once we get more stuff on here, it's not going to work, right? I don't know what to say. I'm just going to leave it like that till it gets slow, and then we'll drop it down. All right, back to questions. Sorry, so is the circular buffer recycling threads after they are done processing? I wasn't clear on why a circular buffer was chosen. Okay, so the reason that I wanted to choose a circular buffer, let's go ahead and open up Blackboard. The reason I wanted to choose a circular buffer is because I didn't want people to think We did lose a little bit of our drawing. I didn't want people to, in the code, I don't want them to have to think too hard about what's going on, right? So the reason I chose a circular buffer is basically what we need here, right, is we need something where we're going to put stuff into it that needs to be done, right? And then stuff is going to come out of it asynchronously, right? So we're putting stuff in, and then we're grabbing stuff out, right? So we like put in A, we grab out A, we put in B, we grab out B, and so on, right? And what happens is, these things we want to be able to happen over a long period of time potentially. Like, let's say we want to use this for background decompress, or like filling those ground buffer chunks. We want that just to happen in the background. So if we have a queue where we don't know how long things take, there's never a point where we're going to complete them all. In the render queue, we did stuff where we just like queued up a bunch of stuff and then said go, and everything gets cleared out. If that were the case, we wouldn't really need the circular buffer. But since we have things that we want to just take arbitrary amounts of time, and we just kind of have a rolling queue of stuff that needs to happen, we don't ever have a single point in time where we're going to clear everything. We're constantly adding new things in as we're pulling old things off, and it just goes forever. And so in that, I want to be able to, the circular buffer is so that I can just keep having that rolling window of things that threads are supposed to take when we go to use this queue for stuff like background art creation and stuff like that. I just saw you where you're sleeping threads if there was no work. Are you still using semaphores to block and wake up threads, or did you switch to sleeping threads? So sleeping is a bad term. We're not using any sleeps on the threads. They're actually waiting on a signal. So I should say wait. See if there's any more questions. Is the archive going to save correctly? We can get it from Twitch if it doesn't, but we would hopefully it did, but I don't know. Would it be easier to implement the queue as a linked list so it has no maximum size? Since we never need to traverse the list, it should still be fast. Well, I mean, linked list has a maximum size, right? It's the size of memory. And if you allocate the memory every time, then you're incurring a bunch of cost to enqueuing things. So you don't really gain anything. Like, unless you actually want to have unbounded queues, it's strictly a lose to switch to a system that doesn't enforce a maximum size, right? Because everything is worse in that system. The only thing you gain is no maximum size. So we have to ask ourselves, do we ever want an unboundedly growing queue? What would the circumstances be under which that occurred, and why would we want to allow it to occur? And as far as I can think of, there's never a case where we actually want that to happen. So it seems better to me just to not allow it and let everything else be better. In the rolling buffer, you check the entry to be filled before writing a new one in, and otherwise skip to the next slot? No. Right now, we actually just, it's a hard error. It's considered an error to write into the queue if you, in that circumstance. So right now, it's just an error. Totally an error. So. All right, looks like we're done with questions. I will now start the process of figuring out if the video is good or not. Who knows? It might be, it might not be. We'll find out. And to answer the question of why I have to do it this way, it's because people complained that the audio quality had clicking in it, and they were correct, when I plugged the microphone into the front port of the computer, because apparently the front port produces that clicking sound, although it doesn't actually produce the clicking sound. It's only when OBS is capturing that port that it produces the clicking sound, so it's like something with OBS in that port. So I have to plug it into the back, which means I have to plug it back to the power cable, which means I can bump the power cable if I have to, tighten it, and it's a disaster. Modern computing. Yes, these are unsolved problems. Why is this ever a problem? Why doesn't the front port on the computer work? I have no idea, because that's computing these days. Anyway, that is computing these days, but there are small things that are always fun and reassuring, like having your software renderer run at 1920 by 1080 by 60 hertz, which is pretty darn cool. So there's at least something awesome happening. Anyway, I'm going to wrap that up for today. Yes, I know Chrome didn't shut down properly. That's because the power went out on the computer. But thank you very much for joining me for another episode of Handmade Hero. We were able to wrap up our multi-threading of the renderer today, which is awesome, and it worked really well. So next week, what we're going to do is we're going to go through and do a polish pass on some of this stuff, where we'll actually do some timings, and we have to go in and make it so that our tiles are well aligned so that we don't have to do all the nonsense with clipping them and the stuff that we're kind of doing in there right now. So we got some cleanup stuff to do, so next week will definitely be a cleanup week on that when we'll sort of polish everything up and make it nice and pretty. But it's running darn fast right now, so I'm pretty psyched about that. That is pretty darn cool, people. So I hope you're happy about that. I know I am. I hope to see you back here next week when we can kind of play around with things and get everything tidied up, because I think it's a pretty sweet renderer now, actually, all things considered. So yeah, come back on Monday. We'll do it. We'll get it going. In the meantime, if you would like to follow along with the source code at home, you can pre-order the game, and it comes with the source code. You can download it every night after I'm done working on it, and play around with it. Just you know, it's a good way to learn. We also have a forum site you can go to ask questions. We've got a Patreon page if you want to support the video series. We've got a tweet bot that tweets the schedule. And of course, we've got a little button that tells you when the next one's coming. And of course, I don't update the schedule till usually Sunday. So the next button doesn't really help you till then. But then it will tell you every day of the week when the next Handmade Hero will be. So that's pretty handy too. Thanks everyone for joining me. And don't forget, one of your esteemed moderators, Abner Coimbray, is giving a lecture on Twitch on Sunday, 5 p.m. Eastern Standard Time. So that's actually 2 p.m. our time, I believe. And that's at twitch.tv/Abner Coimbray, ABNERCOIMBRE. But you can always check the Handmade Hero Twitter. I'll retweet it if he tweets it out. All right, thanks everyone. Take it easy.